Now, I did, you can just use the same notes from yesterday, but I did rearrange it a little. So I'm just going to go through the slides. These are the ones that we did yesterday. This is what the ellipse looks like. It's got all the parts labeled. Here is a little nice quick reference table with the ordered pairs for vertices, focus, and co-vertices. As you saw yesterday in the homework, most of the questions only ask you to fill in the vertices. It didn't ask you to list the co-vertices on any of the questions. Later on, towards the end of the homework, it actually also asked for the focus points. It did ask you to find the E value, and then just remember that C divided by A. And then these were the examples we did yesterday. And the first one we're going to do today is example. So today we're going to be writing the equation of the ellipse. So just like with the parabola, if it helps you to give yourself a visual and graph the information that's provided to you, you can do that. Now, on the previous slides that I just went through, remember yesterday on the bottom of one of the tables, it told you that the major axis length was always equal to 2 times A. So that's what I'm going to be using here when they give me the major axis length. If it were the minor axis length, I would be setting it equal to 2B. Now, let's go ahead and give ourselves a quick little sketch and a visual. So that way, in case you didn't understand where your major axis is just by looking at the ordered pair, you're going to see it because the vertices are either going to be on top of each other, and the same thing with the focuses, or side to side. So if I give myself a quick little visual here, draw my axis, put my center here at the origin, and then my focus points are on the y-axis. They're here at 0, 3 and 0, -3. These are my focus points. Remember, the focus points are always on the major axis. So you notice how they're both sitting on that y-axis? Another clue I could have looked at is notice the 3 is in the y spot of my ordered pair for my focus. So this tells me my major axis is going to be vertical because it's under the in the y spot. So this tells me that I'm going to be placing a squared underneath the y squared. So that's my major axis. Remember, the location of a squared is always under the variable that's your major axis. So because my center is at the origin, I'm just going to use the simple equation. Remember how I modified it and I put x squared always in the top of the first fraction and y squared in the top of the second fraction. Because my major axis is the y-axis, I'm going to put a squared under the y squared. And then the b squared goes under the x squared. So my major axis is vertical. I can see with the visual I gave myself. Again, remember the focus is always on the major axis. So let's go in. We need to find the value of a squared and b squared. When I'm writing these equations, the only thing I'm filling in is the value of b squared and the value of a squared. So let's go ahead and see what we have. So I can find a squared by setting my major axis length equal to 2a. So 2a equals 8. I'm going to solve for a. My a value is 4, but I don't need a, I need a squared. So then what I can do is square both sides of my equation. So a squared equals 16. I need to find b squared. I'm going to use the formula I used yesterday. The c squared equals a squared minus b squared. Because I can figure out c by my focus points. If you recall from that table, this ordered pair for my focus is going to be 0, plus or minus c. This is when the major axis is vertical. Now, also remember that your c value is the number of spaces away that the focus is from the center. So because I gave myself this little visual here on my graph, I could have also realized that there's 1, 2, 3. There is 3 spaces between the center and the focus. So this is my C value. Again, C is how far away is your focus from your center. The A value is always how far away is your vertex or your vertices from the center, and the B is the co-vertices. So since I know C and I know A, I could take my C that's over here. C equals 3, so then C squared equals 9. I'm going to take them and plug them into this equation. So 9 equals 16 minus B squared. I need to solve for B squared. So I'm going to subtract 16. Negative 7 equals negative B squared. Divide by negative 1. And B squared equals positive 7. Now, I don't need to square root it because remember, all we're doing is filling in B squared. So now I can come back up here where I wrote my equation, and my final answer here is x squared over 7 plus y squared over 16 equals 1. And you're done. The next one, let's start identifying our pieces. Now again, if it helps you to give yourself a visual, you can do that. Now, when your center is at 0, 0, again, remember your focus points, your vertices, your co-vertices are on the axis. So again, when the center is at 0, 0, this focus point is plus and minus C, comma 0. So right there from my focus point, I can see my C value is 2 and C squared is 4. Remember your vertices. When the center is at 0, 0, this is plus and minus A, comma 0. So my A value is 3, so A squared is 9. Notice in both the focus and the vertices, the location of the number part of that order pair is the X. So this tells me my major axis is the X-axis. So this is actually horizontal. And I know I'm going to put A squared under X squared, because that's where the number was on both my focus and my vertice. So it's here. Oops. It's in the X spot of the order pair, and here, same thing. The focus and the vertices are always on the same axis. They're always on the major. So now let's go ahead and figure out what B squared is. And let's go ahead also and write down which equation we're using. So again, because the center was at 0, 0, I can go ahead and use this one. X squared, y squared. And because it's horizontal, my A squared is under my X squared. Again, only thing I'm looking to fill in is the A squared and the B squared. I already have A squared, but I need to find B squared again by using C squared equals A squared minus B squared. C squared is 4. A squared is 9. I don't know B squared. Minus 9. Negative 5 equals negative B squared. Divide by negative 1. And B squared equals positive 5. Again, don't square root it, because remember, all we're doing is plugging in B squared. So final answer, X squared over 9 plus y squared over 5 equals 1. And you're done. Now, if it helped you to draw it, you could have graphed those order pairs. But again, when the center is at 0, 0, it's pretty much whatever numbers you see there, that's usually your A or your C, depending if they give you vertices or focus. All right, let's try the next one. 5. Slide. Yes, I did. Now, I actually modified the notes from yesterday. Number 7 is fine, but when we get to number 8, I changed the word on your notes. It did say major, and I changed the word to minor. So when we get to number 8, if you just want to change that word. But let's do number 7. So again, if you need a visual, let's go ahead and do this. Now this one, just like with the parabola, they're giving us a point that's on our ellipse. So this ordered pair that the ellipse passes through is going to be your x and your y value. So let's go ahead and realize that here, if I have vertices here at 0, 5 and 0, -5, this can show me that my major axis is going to be vertical, because the location of the vertices are on the y-axis. So this tells me that it's vertical, and this tells me that a squared is under y squared. So you can see that your center is going to be located here at the midpoint. Again, remember when the center is at 0, 0, this ordered pair for the vertices was created by doing 0, plus and minus a. So now my a value is going to be 5, but a squared is 25. So let's go ahead and write down the formula that we're going to be using. X squared over b squared, because my major was vertical. Now again, remember our goal here is only filling in a squared and b squared. I have no idea what b squared is, and unfortunately I don't know what c squared is either. But I do have an ordered pair. So now what I'm going to do is I'm going to be plugging in the 4 for the x and the 2 for the y, and now solving for b squared. So I could plug in a over here and then square it. So let's go ahead and fill those 3 numbers in. So I'm going to be filling in 4 for the x squared, or 4 for x. And then I don't know b squared. My y value is 2. My a value was 5. I need to simplify all those exponents, or evaluate those exponents. So 4 squared is 16. 2 squared is 4. 5 squared is 25. And that's not an equal sign, that should be a plus sign. All right, so my goal is to solve for b squared. So I need to get everything away from it. So the first thing I'm going to do is subtract the 4 over 25. From both sides. So it's gone from here. In order to subtract 1 minus 4 over 25, I'm going to change this whole number 1 and make it 25 over 25. So now I have a common denominator. So now I get 16 over b squared equals 25 minus 4 is 21 over 25. Now I need to solve for b squared. When I see 2 fractions set equal to each other, I think I'm gonna treat this as a proportion. Now, you could multiply both sides by b squared to get it out of the denominator, then multiply both sides by 25. But I find it a lot easier if you see 2 fractions set equal to each other, do the cross products. Treat it as a proportion. So I'm going to be multiplying 21 times b squared and then 16 times 25. 21b squared equals 400. Divide by 21, and b squared equals 400 over 21. So now let's go back and fill in, because this is my goal, to get what b squared equaled. So let me go back up. So again, the equation I'm plugging it into is this one. So I'm going to be doing x squared over 400 over 21 plus y squared over 25 equals 1. Now, some textbooks, when they teach this concept, will allow that fraction in that denominator. However, we're going to fix it. We're going to move the 21 to the numerator. So essentially what we're doing, let me just show you the math behind it, but bottom line, all you need to do is take the 21, move it to the top, and it's going to become 21x squared over 400 plus y squared over 25 equals 1. But let me show you the math behind it. Remember a fraction bar, so if I'm just working with this first fraction, x squared over 400 over 21, this fraction bar means division. So really what it means is x squared divided by 400 over 21. Remember, when you divide fractions, you do a keep flip change. So change it to multiplication, flip it upside down, and then it's 21x squared over 400. So that's how I got the new fraction. But bottom line, if you have a fraction in your denominator, to get rid of it, we would flip it up to the top. So that's your final answer there. Okay, let's try number 8. Now, notice this time in my vertices, there aren't any zeros. So this is going to be a clue that my center is not at the origin. So this one would definitely be a good one where I would want a graph to see where my major axis is. Are my vertices going to be on top of each other, or are they going to be side to side? So if I do a quick little sketch here and graph 1, 2, 3, 1, 2, 3, and then 1, 2, 3. So if I graph 3, 3, which is here, and positive 3, negative 3, you're going to see that the vertices are up and down. They're on top of each other. So this tells me my major axis is going to be vertical. You can already see that the two numbers that's changed are going to be the axis that's major. But again, give yourself the visual. Now again, I changed my notes. I'm going to be doing the minor axis length, and that's going to be a length of 2. Now, also from my graph, I can either choose to do the midpoint formula to find the location of the center, because remember, the center is equidistant from each of these endpoints of the vertices. So the vertices are always the endpoints of your major axis. So to find my center point, I can either take these two order pairs and do the midpoint formula. x1 plus x2 divided by 2. y1 plus y2 divide by 2 gives me 6 over 2 and 0 over 2. So the center point is the order pair positive 3, 0. This is my center. Remember, your center is the h and the k in the equation. Now, I can look here and find my a value. Remember, the a value is how far away is the vertex from the center. So if I look here, I can see that it's going to be 3 spaces away. So the vertex is 3 spaces from the center. So my a value is 3. making a squared equal to 9. If you recall from the beginning slides, remember that the minor axis length was equal to 2 times b. So if I set 2b equal to this 2, this will give me my b value. Divide by 2, b equals 1, so b squared also equals 1. Remember when you plug things into your formula, all we were plugging in was a squared and b squared, but this time we also have to plug in the center, and our center is at the 3, 0. So let's go ahead and fill in. So again, remember your major axis was vertical, so that's where the a squared is. So it's x minus h squared plus y minus k squared equals 1. This is always the setup. I'm always putting the x squared on the top of the first fraction and the y squared on top of the second fraction. What's moving is the a squared b squared. And because it's vertical, a squared is under the y. And then the b squared is here. So now I'm going to fill in my b squared value, my a squared, and then also my h and my k. So let's fill those numbers in. So x minus 3 squared over 1 plus y minus 0 squared over 9 equals 1. Now, I really don't need to put the 0 in there with the y or the 1 in the bottom of the first fraction. So simplified, here is your standard form. Let me see, somebody sent a message in the chat. All right, so let's look at number 7. Did I skip? Last 2 examples. So again, on your notes, change this order pair to a 4, 0. So what I have up here on the slide. So again, if it helps you to give yourself a visual, do that. Because notice, one of my focus points is 0, 0. So that tells me my center is not going to be at the origin, so I do need to use the longer formula. So I'm doing this one. Again, these are always the same, the tops. Again, what moves is the denominators. And for here, I can see that the number here in my focus is in the x of the order pair. So a squared is going to be under the x squared. So this is what I'm filling in, but let me go ahead and graph this. So a focus here, and then a focus here at 1, 2, 3, 4. And again, notice this time the focuses are side by side. So this tells you your major axis here is horizontal. Again, we can find the major axis length by setting the 8 equal to 2a. Divide by 2, a equals 4, so a squared equals 16. Now, I can also find my center point by finding the midpoint of the 2 focus points, or you can just look at it since we graphed it, and it's got to be the midpoint of the 2 green points, which is going to be the order pair 2, 0. You could have also taken the 2 focus points and done the midpoint formula, add the x's, divide by 2, add the y's, divide by 2, and the center point is 2, 0. 4 divided by 2. All right, so now I can find my c value. Remember, the c value is how far away is the green from the yellow. And you can see that it is going to be 2 spaces away. So that tells me my C value. So if I know that C equals 2, then C squared equals 4. I need to find B squared. So that's why I had to find C squared, so I can use the formula C squared equals A squared minus B squared. C squared is 4, A squared is 16, and I don't know B squared. I'm going to subtract 16. Negative 12 equals negative B squared. Divide by negative 1, and B squared equals positive 12. So I'm going to go up to my formula. I'm plugging in B squared. I'm going to plug in A squared. And I'm also going to plug in my center, which is the H and the K. So let's plug everything in. So X minus, let me not do it in highlight. So X minus 2 squared over 16 plus Y minus 0 squared over 12 equals 1. So again, I can simplify that Y minus 0, and I can actually just change this to a Y squared. Let me just erase. And that's your standard form of this ellipse. One last example. Again, if it helps you to have a visual so you know which way your major axis is, let's graph the 2 focus points. I have one at 0, 0. I've got another one at 0, 8. Remember, the center will be the midpoint between those 2. So you can do the midpoint formula, 0 plus 0 divide by 2, 0 plus 8 divide by 2. So 0, 4 is my center point. You could have also just counted the spaces. So that's your center. Focus, focus. Remember, the C value is how far away is the center from the focus. So you can see that it's 4 away. So my C value is 4. So then I know C squared is 16. Remember, your major axis length is equivalent to 2 times A. So I set 2A equal to 16. Divide by 2, A equals 8. If A equals 8, then A squared equals 64. So the standard form that I'm using is going to be X minus H squared plus Y minus K squared. My axis was vertical, or my major axis, so the A squared goes here, the B squared goes here, and it equals 1. I'm going to fill in my H and K, which is my center. I'm going to fill in my B squared, which I found over here to be 12. And then I'm going to fill in my A squared, which is 64. So let's put all those pieces in. So it ends up being X minus 0 squared over 12 plus Y minus 4 squared over 64 equals 1. And again, you can simplify that X minus 0 and just make it an X squared.
Miss Carter, isn't the B squared with the equation above?
I'm sorry?
Isn't the B squared with the equation above?
Oh, thank you. Yes, it is. Let me go back, so I never found it. All right, time out. Let me go back. This is not B squared. Let's do it for this problem. So C squared equals A squared minus B squared. So C squared is over here. It's the 16. And my a squared is the 64. Thank you very much. Minus 64, and I get negative 48. Divide by negative 1, and b squared equals positive 48. There is the correct standard form for that ellipse. Gets too messy. All right, so there you go. So that is writing equations of ellipses. Again, you do have a WebAssign assignment. It's 6 problems. However, it is not due until Friday. I will give you tomorrow's class time to work on it. And then if you get stuck on anything, you can also use tomorrow's class time to ask me any questions about the tests that I just released if you have questions. And then on Friday, we'll just review. And then when we come back, we're going to do completing the square for these. So that's what we'll cover then. We'll probably do a brief review of everything we did this week. And we'll probably have a quiz that first week after we review some concepts. Again, nothing's official yet, but be ready to probably take a quiz on this shortly after we come back from Christmas break. We will review it, but it'll be a quick, brief review. Any questions? All right, so if you want to start working on it, you can.